Well, good afternoon. Welcome to NASA headquarters in Washington. I'm Dwayne Brown from the Office of Communications. Today, you will hear about Earth and space-based assets that will study a once-in-a-lifetime comet flyby near Mars on Sunday, October 19th. You'll hear brief presentations. Then we're going to open up for questions starting here in Washington, our phone lines, and social media. For our viewing and listening audience, get those questions in. We have the answers at #AskNASA. And of course, there's a lot of social media buzz. Go to our social media websites and sites, Facebook, Twitter. There is a lot of excitement worldwide about Comet, and that comet is sighting spring. And of course, all of the information is on the NASA website at mars.nasa.gov/comets/sighting spring. And that's sighting spring. Okay, before we get started, let me introduce our panelists for today. First up, Jim Green, Director, Planetary Science Division, NASA headquarters, Washington. Carrie Liss, Senior Astrophysicist, Johns Hopkins University Applied Physics Laboratory, Lower Maryland. Kelly Fast, Program Scientist, also at NASA headquarters, Planetary Science Division. And Padma Yanamandra Fisher, Senior Research Scientist, Space Science Institute, Rancho Cucamonga Branch in California. With that, toss it to Jim.
Thank you very much, Dwayne. You know, on October 19th, we're going to observe an event that happens maybe once every million years. And this is where a comet coming from the furthest reaches of the sun's gravity will come to the inner part of our solar system. This comet will fly right in front of the planet Mars. Mars will be blanketed in cometary material. Could I have the first movie, please? As the planets move around the sun in this view, we also see the comet coming in a retrograde motion. And as you can see, it comes from below at a very large distance from the sun, passing right in front of Mars. The comet was discovered by Robert McNaught in January 2013 at his observatory in Australia named Sighting Spring. Now, this Sighting Spring comet comes from the Oort cloud. This is a cloud that's 50,000 astronomical units away, a very distant cloud at the very reaches of the solar gravity. The comet perhaps has been traveling for maybe more than 1 million years to get here. Now, ever since Robert announced the comet in January in 2013, NASA's been getting ready for this event. May I have the first image, please? Now, NASA has a whole series of assets that we're planning to use and have used already in observing Comet Sighting Spring and Mars and its reaction to the comet. As you can see here in the tan color, those assets that NASA has already observed the comet and are still planning additional observations. We see astrophysics missions, heliophysics missions, in addition to the planetary missions. From astrophysics, we have Hubble, Swift, Neowise, Spitzer, Kepler, and Chandra. The stereo, of course, and SOHO are heliophysics assets. In planetary science, we've used one of our balloons called BOPS. Just a couple weeks ago, made fabulous observations of Sighting Spring, and an infrared telescope facility that NASA owns. At Mars, we have a whole series of missions that are getting ready for the event. Mars Reconnaissance Orbiter, Mars Odyssey, Mars Express, which we have an instrument on, although it's an ESA mission. MAVEN, which just got in orbit last month and is getting ready to get its instruments out and be ready for the comet. And of course, Opportunity and Curiosity are eagerly awaiting on the surface for this fabulous event. Indeed, we're getting ready for a spectacular set of observations. But there are some hazards involved. As the comet gets closer to the sun and generates, through sublimation, the long tail that it sees, it carries dust away from it. Now, the dust from the comet may be a hazard to our spacecraft. We've studied and modeled it extensively. And we now know, believe, that when Mars gets very close to the dust tail, which is about 100 minutes after closest approach, all our spacecraft will be on the opposite side of the planet. So the planet will provide the additional protection we believe we need to be able to make these observations safely from our Mars spacecraft. Our Mars spacecraft will be observing it before it gets to the planet and then right afterwards, with opportunity and curiosity on the surface, observing the comet as it flies right in front of them. Well, this is an absolutely spectacular event. And what I'd like to do now is turn it over to Carrie Liss. Carrie's going to talk about the observations from the astrophysics assets that have already been made and those that are planned to be made.
Thank you very much,
Carrie?
Jim. So if I may have my first graphic, please. First, I'm going to talk a little bit more about what we think, why the comet is so important to study. And then I'll talk about what our astrophysics assets have learned so far about the comet and what we hope to learn when it flies by close to Mars. So if you look at the graphic that's up on the screen now, on the left, I'm showing you where the comet has been living. And that's far away in the Oort cloud, the edges of our solar system, just as Jim was describing. The comet was placed there after it formed, we think, in the first million or few million years of the beginnings of our solar system. So it's a body that's older than the Earth. Imagine a body that's about the size of a small Appalachian mountain or downtown DC. It's made roughly of half of rocky dust and half of volatile ices, like water and carbon dioxide and carbon monoxide. And it was formed, we think, originally somewhere between Jupiter and Neptune, and failed miserably in actually accreting and building the planets like billions and billions of its brothers and sisters did. Instead, it got a close approach to one of those bodies and then got thrown out on a very long extended orbit, multi-million-year orbit. So the comet comes back every few million years and has never, ever been closer to the sun than we think maybe Jupiter, Saturn, Uranus, or Neptune's distance. So this is its first passage into what we call the water ice line, where it's really starting to boil its water off. So it's acting very different. It's also its first passage ever by Mars. If you look at the image on the left, the comet is coming in, as we've mentioned, very far away from the sun and from the planets. It's coming at a very large angle. It's very fortuitous that it's actually going anywhere near Mars. And again, if we study the comet, its composition, its structure, it will tell us a lot about how we think maybe the planets were formed. It's also important to point out that all of NASA's missions to comets in the past have been what we call Jupiter family comets that were formed in the edge of our Kuiper belt, in the same disk that the planets move in, not from the Oort cloud. And we can't get to an Oort cloud comet with our current rockets. They move at these orbits are very long and extended at very great velocities. So this comet is coming to us. It's a free flyby, if you will, and that's a very fantastic event for us to study. Let me go to the next slide. Oh, excuse me, pardon me. Back to the previous slide, and on the right, I want to show you that this comet apparition is so close to Mars that if we put it in our own system, which we know much better, it's coming 1/3 of the distance between the Earth and the Moon. This would be extremely close flyby, even a near-Earth object, asteroid object. It's closer than any comet has come to the Earth in the last 500 years. It's that close. What we know of the comet's tail and its coma, its tail would extend from between the Earth to the Moon, and its coma would fill about half the distance between the Earth and the Moon. It's that kind of size object, to give you reference points. So the next slide, please. So here's, I'm showing you the different astrophysical assets and what they've observed from the comet so far and what they will observe during the close approach. Let me summarize to begin with. The assets have shown us so far the comet looks like it's somewhere between 1/2 and 5 miles in diameter. We think it's, again, the mass of a small mountain. For numbers, you want 10 to the 9 and 10 to the 11 tons of material. I mentioned how long, 100,000 mile long wide coma and maybe 300,000 mile long tail. And it's moving, Jim has showed you that movie, because it's moving retrograde, it's moving against the orbit of the planets, it's going to coming in at 33 miles per second relative velocity to Mars. That means very high velocity. So anything that comes off the comet that hits either Mars or the spacecraft is going to pack a real large amount of kinetic energy, a real wallop. So that's one of the things we've been really worried about. This is going to, as Jim also mentioned, this is probably going to be our first capability to ever actually image and resolve an Oort cloud comet's nucleus, and that's going to be pretty exciting. Kelly will talk more about that in a minute. But let me get back to the assets. What I'm showing you here in this slide on the left, this is an optical ground-based image, but I want to set the table here. The big bright glob, that's a globular cluster of stars in the top, but in the bottom of the image is a little smudge with a tail. That's our comet. That's Siding Spring, and that was taken at the end of August. So you can see a nucleus and a coma. That's the bright kind of circular region, and then there's the tail that's fanning out behind it. The next graphic, or the next image there is from WISE, NEO-WISE. It was taken at just a few weeks ago, the end of September, and you're seeing 4 different images in heat radiation that are sensitive to the nucleus and dust coming off from this comet. And you'll notice that the spots, these are 4 different exposures of the comet, and they're varying in brightness. The comet is getting quite variable. That's what WISE is telling us. And you're also, in the next image, you're seeing Hubble, and Hubble has looked at the comet since October, then in January, then in March, and is again going to look at Encounter. And Hubble is sensitive to the dust and the nucleus of the comet. It can tell us the size of the nucleus. That's where we have that size range of half a mile to 5 miles of the nucleus in diameter. Also the amount of dust that's coming off. And we've watched the dust, and we've had colleagues around the world who've modeled how that dust is coming off, and it looks like it's coming off extremely slowly. And that's where we think the hazard to the spacecraft on Mars will be minimal, on and around Mars, especially if we put them on the night side of the planet, or the other far side of the planet when we come closest approach to the comet. The next image is SWIFT. And SWIFT is showing you water molecules that are coming off the comet. So the water ice that's roughly half the comet is boiling off. And that's that nice blue-white image you're seeing. There's also some points. There's a graph, and you'll notice on the graph there's pretty much zero activity until you get up to about June of 2014. And then suddenly you start seeing it rising. That's when the comet got close enough to the sun that water ice started boiling. It's about 2.5 AU from the sun. And so SWIFT has been monitoring that takeoff. Spitzer on the right is sensitive to the dust and also the carbon dioxide that's fizzing off of the comet. And what you're seeing in that image there is the bright extended dust tail that's heading straight up in that image. But there's also a diffuse halo of carbon dioxide gas. We saw the same thing for ISON last year. It's pretty exciting to realize that carbon dioxide may be the most fundamental molecule after water in comets. So those are what have already been seen so far. We're watching a comet turn on, getting active. It's going to interact with Mars. At the bottom are 2 planned observations. On the left is Chandra's, which is an X-ray telescope. And both Mars and comets are X-ray bright objects. We know they emit X-rays. But what we're waiting for is, if you notice, the red in that plot are the different positions of Mars in the Chandra field of view, and the yellow is the comet. When they cross, we're really going to be very interested to see when the comet dumps material in the upper atmosphere of Mars, ions and neutrals, if that's going to make Mars brighten up. Also brand new to cometary science, on the bottom right, is Kepler. So that's the exoplanet finding mission. It's been staring in the Northern Cross for the last 4.5 years, and is now, in its second lifetime, is now looking in the plane of our ecliptic, plane of our solar system. And it turns out where it's staring right now, it started about a month ago and go for 2 more months. The comet, if you see on the very left of that's the Kepler field of view, that cross of CCD pixels, if you will, or CCD fields of view. So imagine that's the equivalent of 1,000, if you will, of your telephone cameras or focal planes. And you see there's white dots on the very left. That's where the comet's just going to graze the Kepler iron cross, if you will. And so one day after the closest approach, for about 25 hours, and then a gap of time, and then another 3 days, Kepler is going to get us extremely precise optical light curves of this comet. And we're going to see if it changes and varies because of its interaction with Mars. So that's what the astrophysical assets that we're using now. And what we hope to learn at the Mars is we're going to see if there's any change due to either both in Mars and in the comet due to this close approach. And just remember also in the back of your head that this is not the first time a comet's ever come close to Mars. It's happened before, and it'll happen again. Finally, I'll leave with this note, and then I'll hand it over to Kelly, is I think it's really exciting to think about. This is a multi-million-year period comet in its orbit. This comet got knocked into the inner system by the passage of a star near the Oort cloud. So think about a comet that started its travel probably at the dawn of man, and it's just coming in close now. And the reason we can actually observe it is because we have built satellites and rovers, and we're now got outposts around Mars. And that's why we can do this close flyby. That's pretty exciting. So I'm done from the astrophysics and the big picture point of view. I'd like to turn it over to Kelly, who's going to tell you what we've been learning from the ground and also from what we're going to learn when the comet gets to Mars.
Yeah, in terms of the planetary science assets, normally you would send a spacecraft to a comet, and in this case, the comet is coming to the spacecraft because we happen to have multiple missions at Mars, so it's a fantastic opportunity. And NASA has 3 orbiters at Mars, and as was mentioned, first order of business was safety and determining if the orbiters would be okay and what to do to keep them safe, and that's been dealt with. And so the second order of business is science. And so you've got all these spacecraft, they're designed to study Mars, but they're repurposing themselves in order to take advantage of this amazing opportunity to study the comet and study what happens to Mars when the comet interacts with Mars, when material is deposited in the atmosphere, interaction with the comet's gas coma. Is there heating of the atmosphere and expansion, and there are meteors, studying the comets itself. So it's a fantastic opportunity. And if I could have the first animation, please. What we're seeing here, we're going to see all the orbiters at Mars. In addition, there's the European Mars Express and India's recent Mars orbiter mission. And then there's NASA's 3 orbiters. We have the Mars Reconnaissance Orbiter and Mars Odyssey and MAVEN. And also here's a schematic of the extent of what is really a very tenuous comet coma and tail. So just an illustration of it passing by, and all those spacecraft there ready to look at Mars. Mars Reconnaissance Orbiter is the one that was mentioned is going to take the first resolved images of an Oort cloud comet nucleus. So that's pretty exciting to have that opportunity to do that kind of science. It's going to look at shape and rotation and the brightness of the nucleus, or really the darkness of the nucleus. It's going to study the coma composition. It's also going to look at the atmosphere of Mars to see if it can detect any changes from the interaction between comet and Mars. Mars Odyssey is going to be studying the coma and the tail of the comet. It's going to take infrared and visible images, and it's going to kind of use Mars as a reference to understand what it's seeing. MAVEN recently got to Mars, and it was designed to study the upper atmosphere of Mars. So as part of its regular science mode, it's going to look at the atmosphere and look for changes in the upper atmosphere due to that interaction with the comet. And so it's ideally suited to that if there is any sort of heating of the upper atmosphere, expansion from the interaction, and looking at those possible effects. But it will also take ultraviolet images of the comet, and it will do a mapping of the composition of the comet. So that's going to be really fantastic. But in addition, there are 2 rovers on the surface. We've got Curiosity and Opportunity. And if I could have the next animation, please. In this animation, we're seeing the comet pass by again, and it's much brighter here than it's really going to be, just so we can illustrate what's going on. But during this time, when the comet goes by, Curiosity and Opportunity are going to turn their cameras up. And here's an animation from Opportunity's viewpoint, again, much brighter, so you can see what's happening as this kind of sped up animation of the comet setting goes by. This is kind of a dusty season on Mars too, and so the dust is going to make the comet even less bright, but still both Opportunity and Curiosity are going to look up, try to image that comet, and we certainly have fingers crossed for the first images of a comet from the surface of another world, so that would be really exciting. So great things going on at Mars, but let's bring it back a little bit closer to home. Here on Earth, there's lots going on. Just recently, as Jim mentioned, if I could have the first image, please, NASA's Balloon Observation Platform for Planetary Science, or BOPS, flew just a few weeks ago. And as part of its mission, it was able to make measurements of the comet, and it was able to do this because of the balloon from above much of Earth's absorbing atmosphere. Now, in addition, there's all kinds of ground-based observations taking place all over the world to study the comet. And if I could have the next slide, here we see NASA's observatory that's involved in making these observations. This is NASA's Infrared Telescope Facility, or IRTF, on Mauna Kea in Hawaii. IRTF meets the challenge with scheduling and daytime observations needed to really get the most out of this opportunity to maximize the access to the science data. It has observed the comet already, and it's going to continue to make observations of the comet's composition, but not only that, also the composition of Mars's atmosphere, again, to see if it can see any signatures of some sort of interaction taking place between the comet's coma and the atmosphere, and what happens from that. Now, all that you've been hearing here, a key part of that is the coordination and communication efforts by the I have to look at the name because I always forget it, even because we've rebranded it from before. But it's the Coordinated Investigations of Comets Group, or the CEOC. They've been fantastic about coordinating also with the Mars Program Office out at JPL to get ready for this event, convening workshops of scientists, being able to foster coordination and collaboration, and to really maximize the science coming out of this, because there's one shot at this, and this is the time to do it. And so they're, having had this lead time, they're getting ready to get the most science out of this. You'll see the JPL website at the end today, I believe, and then also the CEOC's website, cometcampaign.org, has plenty of information. We have some CEOC members here on the platform and off the platform, and so we've been very thankful for their help with getting the most out of this opportunity. The CEOC has also, though, engaged the amateur astronomy community, and so with that, I'm going to pass it to Padma Yanamandra Fisher to address that.
Well, thank you, Kelly. An important component of the CEOC observing campaign is the amateur community, and it's important because it provides an extended observing team as well as extended observing windows that we can characterize the comet, and also allows for outreach via social media. May I have my first slide, please? As Jim mentioned, Comet Sighting Spring was discovered by Rob McNaught. You can see the two pictures on the right side show both the telescope facility as well as the telescope that was used to make this observation. Also, on the left side of this graphic, you see an atlas of the globe, and what you see is that the red dots indicate where we have observers, amateur observers, as well as robotic networks, so that observers in northern latitudes can use them. And they've been continuously monitoring the state of the comet since January of 2014. Now, most of the observers have equipment that ranges from a few inches to 1.5 meter telescopes. They also observe in two wavelengths that are very sensitive to dust and clouds on the planet, as well as dust and gas in the comet features. May I have the next graphic, please? Now, these are some of the observations that have been acquired in the last month or a few weeks from Australia, South America, and South Africa, which are the three locations where the comet will be observable at nighttime. As Kelly mentioned, it's going to be mostly daytime for the northern latitudes. But here we have identified not only observers, but locations and the windows where we can actually get some continuous data for the next few weeks. And you can see that the comet has changed. It looks a little different from the time August to September. And like Carrie mentioned, it is variable, and this is very interesting to see how it's going to evolve in the next couple of weeks. May I have the next slide, please? This graph basically shows the status of the comet and Mars as of last week, simply because what we're noticing is as the comet comes from south of the ecliptic and is going towards northern latitudes, Earth has crossed its orbital plane, and therefore we see different features in the comet that we normally see when a planet crosses the orbital plane, like an anti-tail, which is in the middle middle image of the comet on the left side. But as of last week, it seems to have varying brightness, which is shown in the top right of the comet. But at the same time, Mars has also been observed by the amateurs since January, and what we notice is it's going through its changes of season. So the top right Mars image is from April, when it was closest to the Earth, and you can see a lot of structure and details on the surface. And the two images below that were taken just a few days back on October 5th, where it has entered its northern fall season. Like Kelly mentioned, it's a dust storm season. And there were two dust storms that were observed on that day. And by this point, the disk has decreased to mere 6 arc seconds in the telescope from ground. So this is very interesting that both planet and comet are changing. So the interaction is going to be very exciting. Next slide, please. And this one basically is, in addition to all of that happening, the southern hemispheric sky where the interaction or the flyby is going to occur is a very busy part of the sky. On the left side, you can see the blue rectangle represents exactly where the two objects are going to be crossing their paths. But you can see the rest of the sky is very busy as it passes the LMC, the Large Magellanic Cloud. And so it's, our observers are essentially practicing their observing techniques, also getting familiar with the star field and as the comet and Mars move through that. On the right side, what you see is on the time of encounter on October 19th, basically Australia and South Africa are going to be the best places to see optimally South Africa. And so the blue stars on that map indicate locations where we have identified both robotic as well as individual astronomers that are going to be taking data continuously so that we can actually see what how the dust structures, how Mars's global features, how they change. And that's important even though there are lots of NASA assets that are looking at it. Here you're seeing the far environment, you're seeing the global picture rather than just the nearby picture. So this provides a complementary view of the event. May I have the next slide, please? Now, this, as far as outreach, part of the work is providing resources and access like star charts. Here's a sample star chart that we do provide via our various social media dimensions. And this is essentially if somebody in Australia, in South Africa at Cape Town walks out and takes a look up at the sky, what they can see in the sky are not only the planet Mars, Antares, and Saturn, but you can also see the comet. But this is just a schematic picture. It's not a naked eye object. The comet, you cannot see it like that as naked eye. It's a binocular object. You can see the telescopes. But it essentially helps people to at least know where to look because the sky is so busy. May I have the next graphic, please? And this one basically shows why we study comets, because as Jim and Carrie as well as Kelly have all mentioned, this is a once-in-a-lifetime event for a comet going by Mars. Oort cloud comets, it's hard to plan missions to them because you don't know where they're going to come from and how they're going to behave. So here is a composition of a lot of the images of various comets that are available in our sky currently. And these are amateur astronomers who have taken these images, and they essentially provide the legacy and the data and the reference system against which we can place the other high-resolution observations in context. And that's one of the reasons we study comets, is because they're the remnants of our solar system formation. So back to you, Dwayne.
Okay, thank you. So now we're going to transition into the question and answer period. A lot of questions. And again, for our audience viewing, hashtag #AskNASA. Send those questions in. We have the answers. Join the conversation. There's a lot of it worldwide on Twitter or Facebook, and look at the NASA accounts. Join that conversation. So what I'm going to do here, before we go to the phone lines, see if we have any media representatives here in the auditorium, and then we're going to go to Mr. Social Media himself, Jason Townsend, in a second. Any media reps? I see a hand here. If we can get a mic. If you can wait for the mic, give your name and affiliation, please.
It was announced recently, Marcia Freeman with Executive Intelligence Review. It was recently announced that there would be coordination in data collected by the Mars Orbiter mission and MAVEN, which is wonderful. Is there a method by which is going to be coordination between all of the NASA craft at Mars, Mars Express, and the Orbiter mission, an international coordination?
Indeed, those dialogues go on between the teams. With respect to Indian's MOM mission, we've just started that conversation. The observations that probably relate the most are from the MAVEN team, and both the investigators from those two mission sets are just now beginning that dialogue.
I'll add that the workshops convened by the SEOC and the Mars Program Office had participation from all of the NASA missions and from ESA's Mars Express. and from India's Mars Orbiter mission, they all called in and shared. So there's been communication of plans, and but certainly in the case of the India mission, that's kind of just starting since they and Maven, we just got there and getting set up. So.
And I'd like to add, if you want to go and see what happened to those workshops, they were live streamed and everything's been captured onto the web. So especially the last one, there was a lot of international discussion.
So I think we'll see a lot of really great correlative data being brought to bear and tackling a lot of the science. And that'll require all sorts of data from not only our missions, but the ground-based observations, and the amateur community are more than welcome to join us, of course.
Yes, sir. Wait for the mic and name and affiliation.
I'm Dan Vergano with National Geographic. Do you have any expectation about how long it'll take till you have a full picture of all these observations? It's not like a switch you turn on and it's all immediately cooked, right? It's going to take a little bit of...
I'll take that. That's a very good question. Most of the data that comes down is going to take a day or two to get through the pipelines at the very least. And so, and to be checked and make sure. We want to make sure that the data looks good and that we have removed any artifacts. The good news is that, and I think people's attention is really going to be riveted on the day of encounter itself, October 19th. We're actually expecting to get some good imagery a few days before. Remember, how the comet's going to look is going to be roughly symmetric with the time of closest approach. So what you may see on the day of October 19th is actually an image of a day or two out from the Mars assets. And then you'll start seeing over the next week or two, you're going to see more data come in. And the best data probably won't actually be available and probably till about 3 or 4 days after. We don't want to overpromise. But that's when we're going to really have the close approach. We'll look through it, we'll remove cosmic rays, any sort of glitches, artifacts to make sure. One of the things we're interested in is, are we going to see meteors in Mars' atmosphere? And you have to be careful to make sure that it's not any sort of instrument issues.
Any other questions? We're actually going to go to the phone line, so we have a hand here. Wait for the mic and your affiliation.
Hi, my name is Selena. I'm from Talk Radio News Service, and I would just like to ask, how long will this whole study last for? Will it, after October 19th? I mean, you have a couple days for all of your data to come down, but overall, how long would it take?
Well, yeah, certainly, it's just, the encounter is that day, and it'll take some time to get the data down from the spacecraft days. But then there's so many observations involved, and there's the quick look pictures, which everybody will try to get out there as quick as possible, and the early results. But then the science analysis will go on for a long time, especially to get all the science out of all the data that aren't necessarily pictures. And so it will extend for a long time. But I know that scientists will want to work as fast as possible to try to get more results out at some of the major meetings that will be following, like perhaps the Division Planetary Science meeting, American Geophysical Union meeting, LPSC, Lunar and Planetary Science Conference. So I imagine over the next year it'll continue to dribble out, but hopefully in the first few days, some quick results.
That's a very good answer. If I may just add, is that our Comet ISON experience last year, the first science papers came out within about 3 months, but then we're still getting the bulk of the papers are coming out now. So expect most scientists to come out with the real serious results within about a year and a half after the event.
I'd like to add to that too. In addition to all the professional as well as the assets that are going to be taking data, the amateurs tend to have a longer timeline. As a comet is interesting, even after as it's receding, they still take data, and so there may be other pictures that come out of it in different type of features that might be seen in a tail that you normally cannot predict, but you can have long tenuous tails and disconnection events or other things. And so on the amateur side, the timeline might be longer as interesting features present themselves. So it could be months, maybe 4 or 5 months later on.
And we didn't really highlight here some of the NASA assets are going to be continuing far out. I know like the Swift observations are going to continue for a long time, and NEOWISE. And so, yeah, it is the gift that keeps on giving.
Well, that's a very important point which we didn't highlight. The comet is going through perihelion, its closest distance to the sun, 5 days after it's closest to Mars. So then basically it just starts going out of the solar system again. Assuming it survives the Mars encounter, we're actually going to watch and see if there have been any changes because of this first passage through the inner system. So just as Kelly and Padma mentioned, following this comet back out again is going to be very important, as well as the flyby by Mars.
If there's one thing we've learned about comets, and that is they're very unpredictable. And indeed, that's why we want to keep watching. You know, as it passes by Mars, that's a gravitational perturbation interaction. What does that do to the comet itself? Does it break it up? Does it rearrange it? You know, so the observations are going to really be critical to hang in there and continue to be made well after it passes by Mars.
It certainly will be a gift that keeps on giving, that's for sure. Okay, so what I'm going to do here is go to the phone lines next. We'll have an opportunity to come back. So we'll do the phone lines next, and then social media, and come back here. I believe we have Irene from Reuters on the call. You're up, Irene.
Hi, thanks very much. I have two questions. The first is it just a coincidence that the orbiters are going to be on the opposite side of the planet after the area of most concern, the time of most concern with the tail passing by Mars, or was some tweaks made in the orbits to make that happen? And I have a follow-up.
Okay, yeah, that's not a coincidence. After all the modeling was done, and one of our SEOC members here led one of the modeling groups to look at the hazard of the spacecraft. Once that was determined, and the timing, which is really important, when is the time of greatest risk? Once that was determined, then plans were put in motion and the studies were made to rephase the orbits, to do the maneuvers needed to make sure that the spacecraft are on the far side of Mars during the time of greatest risk. So it is part of the plan.
Okay.
You have a follow-up?
And then just following up on that last comment, is there any assessment for the likelihood that the comet will be destroyed during its pass by Mars?
Well, I think it's unlikely that it'll be destroyed in the sense that we won't see it as continuing to sublimate, creating a coma and a tail. But whether it retains its structure or not is of interest. You know, whether the gravitational perturbations are so great that it breaks it apart. I think astronomers don't believe that will happen, but you know, we want to be able to look at it and continue to make observations to determine that.
I'd like to add to that, it's a very good response, is that we did see in 1994 a comet called Shoemaker-Levy 9 that hit repeatedly into Jupiter because it had flown so close by 2 years before that, in 1992, that it got ripped apart. We don't think that in the case of Siding Springs, Mars is a much smaller body, much less mass than Jupiter, and even though we're coming that close to Mars, very close to Mars, most of the models argue that even though a comet is also very weak, think of the strength of maybe meringue and lemon meringue pie or talcum powder in a pile in your hand. That's how strong comets are. Even though they're the size of a mountain, they're incredibly weak. It's amazing that they're still around after 4.5 billion years, but most of the reason for that is that they've been living very, very far away from the sun, and they've been deep freeze, just kind of in a time storage vault. But Jim's right. We don't know. If we knew everything about comets, we wouldn't be studying them, and they wouldn't be that interesting and variable and enigmatic, and they are, all of those things. So if we don't look, we won't find out. And there is a possibility that the comet may have already broken up a little bit. There's a possibility that Mars may drive some more activity. That's why we're looking.
You know, one of the things that we've been monitoring, of course, is the intensity of the light from the comet over a period of time. And it was for quite a while, actually, at a higher level than what we originally predicted. And then it dropped well below that. So we don't know how that relates to what was happening with the nucleus. And so our Mars assets, when they turn and they're able to get a good look at high resolution, and it's only going to be maybe half a dozen or a dozen pixels, but whether that's what looks like a solid shape or actually a couple shapes, that may really fit in the puzzle very nicely as to how come the comet changed in brightness over time.
Next caller is Alan Boyle from NBC. Alan?
Thank you. I had a question about the composition. Since this is coming in for the first time from the Oort cloud, do you already have a sense of how those Oort cloud comets are different? What do you expect to see in terms of compositional analysis as the comet comes closer? And does this have any bearing on the whole issue of planetary defense? You know, the deep impact scenario. I don't suppose that you've got that figured out, but what do you expect that community might be able to gain from this sort of encounter? Thank you.
Well, our naive expectation for the composition is that because this body was formed out past the water ice line and then was thrown out of the solar system very early on, that it should have actually more of the really volatile ices, methane, carbon monoxide, things that boil off very easily. It's never, if you will, been heat treated very, very strongly before, compared to the comets that, like the Tempel 1s or the Wild 2s, or the Gerasimov-Gerasimenko, the Rosetta target, that we're coming very close to, right, that we're actually flying by or rendezvousing with. And those comets have been around the sun and the inner system for many, many, many passages. So our naive expectation is that there will be more volatile organic ices in Siding Spring. That being said, that also might be what created that initial bump up of activity Jim just related to it. We think it could possibly be either due to the fact that it's almost like nitrous oxide in your gasoline engine tank, that those hypervolatiles could have actually increased the activity and created the activity that let us see this comet almost out by Saturn's orbit to begin with. There's, put it in a different way, there's no way we would see a body that's between 1/2 and 5 miles in diameter out by Saturn. It's just and very dark. It's way too small. The only way we saw this comet, detected it so early, more than a year ago, was because it was very active very far out. So our naive expectation is that that activity may have actually been driven by the very first passage into the inner system, and then it's now slacking off. That could be one reason why it's run out of these hypervolatiles. Another is that it could have broken up, because it's, again, never been stressed and heat treated much before. It's never been in the inner system. The other thing I would say is that what we learned from Comet ISON last year is Comet ISON looked like it was very carbon rich, maybe organic materials rich. So, and that was another Oort cloud comet. So we're guessing that Siding Spring should show us an awful lot of organic carbon-enriched material.
So let me sort of address the near-Earth object aspect of your question. And I think it's easy to do in the sense of what we're seeing in the long run. You know, in the last couple of years, we've really stepped up our observations of near-Earth objects. We have a lot more observatories. We put more telescope observing time and can see a larger part of the sky. And we're now seeing some new trends that we haven't seen before. If you look back in history, the number of Oort cloud comets we observe are just a matter of 3 or 4 a century. We do see a lot of comets, but those are all short period comets that exist in and around the period of going out to Jupiter, or maybe even a little bit into the Kuiper belt, but not many from the Oort cloud. But more recently now that we've really picked up our observations, we're now seeing many more Oort cloud comets. Actually, there's 3 up right now. There's Siding Spring, there's another one called Pan-STAR, and there's another one called Jacques. Mm-hmm. And we believe that our near-Earth object set of observations that we're making now are becoming much more comprehensive, and we're getting a much better view of what's happening in our solar system, and that's just going to continue to increase. So I believe we'll continue to find not only near-Earth objects, but these comets, because as they move across the sky, that's how we detect them from the background of stars very far away that don't move in the frame of our telescopes. Okay.
Hey, next up, Tracy Watson from USA Today. Greetings, Tracy.
Hi, Dwayne. Thanks for taking my call. I have a couple questions. First, I understand that the modeling has shown that there's going to be very little big dust falling on either Mars or even reaching its orbit from the comet. So can you talk about whether you really expect to see meteorites over Mars, and also what the hazard would have been if the spacecraft hadn't been moved to the backside?
Well, at least to answer the first part of that, I'm going to actually kick that to somebody who did the modeling. So if we could send a mic over here, I'm going to have Tony Farnham of the University of Maryland answer that question, since he was involved in helping to make that assessment.
Yeah, am I on? Okay. We did the modeling to look at the hazards of what was going to go on at the time the comet encountered Mars. And it's kind of a strange situation because this comet gets very close, but it actually doesn't, the dust that comes off the comet actually doesn't make it to Mars before it's blown away by solar radiation pressure. So the expectation is that very little of the dust will actually hit Mars. The biggest hazard actually occurs after closest approach, as Jim said, when the big dust that sort of trails behind the comet may reach Mars as Mars crosses the comet's orbital plane. The velocities that we see in the comet suggest that's not going to happen because these are big particles and they would have had to have been emitted long before perihelion, something like 2 years before perihelion. And from our observations, that's not, they suggest that that didn't happen. So the hazard is, the expectation of the hazard is very small.
Yes, and in terms of what the engineers from the mission projects did, they took this information and then they did all the amazing work that they do, looking at probabilities and looking at what would happen if there was a dust particle coming in at it was, I guess, 33 miles per second, yeah, get in the right units. What it would do to different components on the spacecraft, how they might have to orient the spacecraft, or all those different trades that they would have to do. And so ultimately it was decided the best thing to do is, yeah, the risk is small, but it's there. And so what we can do is change the orbits so that at least during that period of greatest risk, the spacecraft are on the other side of Mars. So they'll be able to do the science, they'll kind of hunker down and they'll do the science again. And so the expectation is that it will all be okay and that all the precautions have been taken.
I'd like to add that this was actually a very important thing to study. If you think about meteor showers on our own planet, when we see them, it's usually because we're passing through a comet's orbit or where an asteroid, that some asteroids also shed material, that we're passing through its orbit. I can't think or recollect a time when we passed through that orbit about an hour and a half after the body just went by. All right, so that doesn't have, we usually go through an old part of the orbit when the comet is way around another part in the orbit, many months to years past us. So it was a perfectly reasonable and important thing to do to worry about this hazard. It's actually amazing the hazard is so low, but we've had 3 different groups, international groups, telling us that not to worry.
Okay, we're going to take one more question from the phone, and then we're going to go to social media, and then we're going to wrap up. So we have Kelly Beatty from Sky and Telescope. Kelly.
Thank you. Most of my questions have been answered. I'm going to pass and let somebody else.
Okay. Excellent. Let's go to social media. Jason, what's going on in the social media world?
Indeed. We've got several questions from both users on Twitter and from those that are watching on Ustream here. First one comes from Hector, who asks, I know the numbers were crunched many times and 83 miles is awfully close. What are the chances of a spectacular Mars collision?
That's 138,000 kilometers or 88,000 miles is the closest approach to Mars's center. So it's a little bit farther away. The error bar on that, if I believe, is in the order of maybe 10,000 miles. So I believe there's almost 0 chance of the comet hitting Mars. The short answer.
Wonderful then. Twitter user DMS asks, will a spectacular meteor shower follow up on the brush of the coma with Mars' upper atmosphere, and will the rovers and orbiters be able to see it? Meanwhile, at the same time, user T asks, will Curiosity and Opportunity be able to get photos of that, and if there's any rain of debris?
Well, they certainly will look, and even like the rovers are going to look up, and I forget which orbiter is going to look at that, and also the Hubble Space Telescope is going to, as part of its science, is going to take a look at that. But as Tony Farnham explained, the risk is probably, or not the risk at this point. The odds of that happening are minimal, but that still could happen. And so, again, you don't know if you don't look. And so we're going to take a look at that.
So a byproduct of the hazard modeling was that it told you how many particles we expect to be hitting both Mars and the spacecraft. So the hazard modeling tells you what direction to look to see those meteors. And if I understand, to quote Tony, who's in the audience, is that I believe they do expect some meteors, but it's going to be a little bit above the normal background rate just from passing around the solar system. So if you look very carefully one place in the sky, you might see a bit of enhancement, but not much.
So one thing we do know is where Opportunity will be and where Curiosity will be. So at closest approach, Opportunity will be just coming out of dawn, and Curiosity will be going into dusk. So within a few hours after the event, Curiosity will be on the night side of the planet, may even be able to observe even smaller particles that may make it there. On the day side, Opportunity will have to be looking up, and that is indeed planned, but indeed larger particles would have to make some sort of fireball or some sort of trail for it to be able to see. But as they say, we've got to plan these observations in advance and wait to see what happens.
Let's take a couple more, then we'll take one more from the phone and we'll wrap up.
All right, then. This comes from a user watching on Ustream here. Will MAVEN be able to get a baseline observation before the effects of the comet occur?
Yes, actually, that's part of the plan. Now, again, they just arrived at Mars, and so the first order of business is to go through the activities they need to do to transition to doing the science. And so they're going to fit this science in. They've even released some science already, but that's the first order of business. If all goes well, then they are going to get a baseline measurement of the atmosphere so they can see what is the difference after the comet went by. So, yes, they will indeed do that.
Excellent, then. Also coming from Ustream here, how long might this dust persist on Mars, and are there any effects on the rovers that depend on solar power?
Referring to dust from the comet, or the dust just in the atmosphere?
I
Okay.
believe.
Well, again, there'll probably be very little of that, and the period, at least like of greatest risk to the spacecraft, and when the meteors might be coming in, would be, it's only about a 20-minute period, so that's actually pretty short when Mars passes the plane of the comet's orbit. So it is a short period.
And if you think about how much meteors affect the dust environment in our atmosphere, it's very small. So we only expect a bump up of maybe a few times the background rate. We don't think there'll be much of an effect on the rovers or on the ground assets.
Okay. So for the social media folks, keep those questions coming in. We'll have some of our scientists get you the answers as soon as possible. What we're going to do here is take one more call from the phone lines and wrap it up for the day. So back on the phone, and Mike Wall, space.com.
Thanks, guys. Yeah, and I just had a question about then what opportunity and also curiosity might be able to find. I mean, is this just sort of pretty pictures that you're hoping to get from the Mars rovers, or is there some science you could glean like from their photos? And yeah, we don't want to get too excited. We don't, but is it possible to get a big fireball photo in the Martian sky? Is that something that that could happen, or would it just be kind of, I don't know, a dim light through the dust is sort of, I mean, what to expect? Should we get excited about those sort of possibilities of what opportunity might return, curiosity might return, or should we just sort of calm down and just wait and see?
Well, I still think it's good to get excited because you got to look, and certainly there is science in the pictures, just seeing what the comet looks like and what actually makes it through the atmosphere, what the light that makes it through the atmosphere, what it sees. But also on Curiosity, the ChemCam is also going to take a look at any mineral information that it can detect from the comet. So yes, there still is science to be done, though we love the pretty pictures too, but there's science to be done also.
I'm not convinced there'll be a fireball picture, but I'm excited just to see the first image of a comet from the surface of another planet. I think that's going to be really exciting if we get it.
I think what I'd like to add is, even though we'll be imaging from Curiosity and Opportunity, Curiosity actually has a really nice set of weather measurements, if you will. So it measures the pressure and the temperature at a really pretty good clip. Now, although right now we believe that most of the effects that will be observed will be in the ionosphere and in the upper atmosphere, we don't believe there'll be many effects in the lower atmosphere where Curiosity and Opportunity obviously are, but we're making those measurements too. I mean, it'd be great to be able to look at those and determine if pressure changes or temperature changes might be attributed to this flyby and the impact of the cometary material. The measurements will be made, and the scientists will take a look, and I know we'll get some great stuff out of it.
Okay, so Jason asked for one more. I can't tell him no, so we're going to go and get one more question from social media. Jason?
Not a problem. There's a couple of different variations of questions on here, all asking about how people can get involved and so on. So, for example, Aubrey from Twitter asks, will I be able to see it from Ohio? Meanwhile, Tim asks, will there be an online feed from the encounter that I can watch? So,
yeah, I think from Ohio that one that probably won't work out. Unfortunately, it's really Mars has the front row seat, and here probably more the southern hemisphere. But there are I don't remember offhand, but there's a social being planned, I believe, but I don't remember the timing of that, and so that might still be in the works. So there's that opportunity. Then there's the websites just to find out more information, the cometcampaign.org and the mars.nasa.gov/comet/sighting spring. They have all kinds of background information, but in terms of the events, you could follow the NASA social pages, I would think, and then once the rest of it forms up, that will be out there. Is that correct, Dwayne?
That's right.
Okay.
I'd also point out that the time when the closest approach is about, it's going to be about there in the middle of the first football game 2 Sundays from now, so it's going to be in the middle of the day for us. But I also want to point out that Padma has been doing an awful lot on Facebook and Twitter, so maybe we should let her comment.
Well, I was going to say, we do have an amateur and it's a professional amateur collaboration group called PACA, and there are ways to participate. All of this is online, as well as there are going to be different social media, including Twitter as well as Flickr albums. So we already have those populated, so you can see the images the amateurs have been taking since January, and so those will be continuing. And even if you're not a member, you can. Many people who take images can upload directly to the Flickr album, so they're available to the public. And also, we're planning to have our own Google Hangouts where people who have taken the data from the different locations in Australia, South Africa, as well as South America can pretty much show what they have taken and pass on the baton, so to speak, to the next location, so that you can actually see what the observers are taking data. Even though Casey says there's football on that Sunday, if your team loses, forget about it and just go to Ustream. and a lot of the rest of the world doesn't watch American football. So there are a lot of, so this is a lot more exciting.
Okay.
Yeah, the telescopes.
All right, so what we're going to do here is wrap up. I would like to remind folks that updates on any images or any activities, go to the NASA website, nasa.gov, and in particular mars.nasa.gov/comet/sighting spring. We want to thank our participants. Save the date, October 19th. NASA's ready. The astronomers worldwide are ready. It's a gift that's going to keep giving, and that gift will certainly help us further prepare for the journey to Mars. Thanks for joining us.